So we're almost there. We got ourselves a TuringPI, we built a supercomputer, we put everything in a nice case. Now we need to get it up and running. So in this episode, I'm gonna walk you through the steps how to flash an operating system to the nodes, either to the RK1 or to a Raspberry Pi Compute Module 4. Now, in this episode, I'm also going to talk a little bit about the different OSs you can load, Ubuntu, Talos, etc. Also, difference within the OS, where to get your images, what to look out for, and then we're going to flash our operating system to our nodes and get our cluster up and running. So for those who do not want to wait, here are the timestamps. I also am going to put them down below. So yes, let's get started. I'm Garrett, and this is TimmerTech. Let's talk operating systems. Currently, the TuringPI supports three different types of nodes. We have the RK1 from Turing machines, the Raspberry Compute Module 4, and the NVIDIA Jetson series. Now we still need to load an OS, and that's what we're going to talk about right now. So what do we have? We have either the ability to do a desktop image, connect a monitor. Yes, that's possible with the TuringPI, but we're building a supercomputer, our own distributed cluster. So we want a server operating system. Now, currently there are, when it comes to the RK1, there are two flavors. Raspberry has multiple options, but I'm gonna make a recommendation to you all. So the two major operating systems currently being supported by Turing machines, especially when it comes to the rock chip, is Ubuntu and Talos. Now, I'm gonna dive a little bit in Talos first. We are not gonna use it, but it's good for you to know about it. It's quite an advanced operating system because it works differently and it requires some expertise to work with. Talos is a immutable operating system, especially designed for use with Kubernetes. Now, what does that mean? It means the operating system is read-only. And that's actually a good thing because it allows for a minimum of operational drift, as they call it. Yes, there are still some files you can change on the OS, like host names, things like that. There is some basic stuff, but overall, the entire root system is read-only, which means it's really hard to make mistakes and you make sure that between nodes there's not much difference. Now, that's actually something for later. We're not going to go dive into that one. We are going to look at Ubuntu. So what I'm going to show you is where to get the images for the RK1 and the Raspberry Compute Module 4. I'm also going to show you where to get the official ones from Turing machines, but also a repository from a contributor on GitHub that has done amazing work for the Rockchip support. He's currently on a sabbatical. However, that actually has a more recent image, and that's what I'm going to use. Now, when it comes to Ubuntu, there are multiple versions. So which one do you need to pick? Well, actually, it's not hard to figure out. When it comes to servers, you want stability and you want to ensure that your maintenance is in order. Nothing is worse than constantly spending weekend after weekend fixing stuff. We want things to run and we want things to be stable. So my advice is when it comes to Ubuntu and then especially the server edition, always go with the LTS version. So LTS stands for long-term support. Now Ubuntu has a release cycle of one release every 6 months. That is in April and October. And they actually name their versions of their releases year.month. So you got versions like 2204, 2210, 24.4, 24.10, and so on. Now, when it comes to LTS versions, it's important to know the following. They are released every 2 years. And the normal release is every 6 months. That means they still release a new version every 6 months. However, those between LTS versions are the regular versions and they have a shorter time for support. Now, the LTS versions have 5 years of support, which means that you can actually wait 2 cycles and then still have another year before you must upgrade it, which is pretty cool and pretty handy when it comes to servers. You still want to update more regularly because you want your system to be secure. But if you have no other choice, you your OS is being supported. Now, which version to choose? Basically, the current version that is LTS is the 2204. So April releases are always the LTS version every 2 years. Now, currently there's already 2404 and 24.10. They are released, but they're not LTS versions. They have not the same time of support. So, and the next LTS version will be in 2026 in April. So that is going to be 2026.04. So for now, just remember, you can go with Talus. If you have a Rock chip, you have an RK1. It requires some deep dive into it, how it works, because it's a lot harder when you do it for the first time. It's great if you want an OS just to run Kubernetes and just don't want to deal with anything and you don't want anything to break. But when you want to have an environment where you can still play around, do custom stuff, Ubuntu server in this case is the way to go. Now, there are other distributions out there that might have also Rock chip support. I do not recommend those. And the reason for that is very simple. Just start with Ubuntu server. There is a lot of information how to run software, how to configure stuff under Ubuntu. So that will save you a lot of time instead of trying to figure out, hey, I got this, how do I adopt that for my current distribution? So that's for now everything about operating systems in relation to TuringPI, what I wanted to share. Let's get some images and let's get started with flashing our operating system to our nodes. You enjoying the video? Comment below, subscribe, and hit that like button. It greatly helps this channel out. Now, let's get back to the video. So there are basically 3 locations where you can get your operating system images in the case of the RK1 and the compute module 4 from Raspberry. Now, We have the official location from Turing machines. We have the open source GitHub repository, and we have the official Ubuntu repository. However, that last one is basically only for the Raspberry Compute Module 4, but I'm going to show it anyways. Now, in case of the official repository from Turing machines and the GitHub repository, here's some interesting information about it. So the guy who built the Rockchip support for Ubuntu that gets everything all packaged together is his name is Joshua Riek. As far as I understand from the discussions right now, he is on some kind of sabbatical, but he's also the one that got the Rockchip support into the image that's currently on the Turing machines repository. So yeah, basically same source. However, his images currently for the RK1 modules are newer. So that's why I'm going to go with that one. But let's get started. Let's run through them. So the first up is the official repository from the TuringPI. I'll put it down. They have the 2204 image with Rockchip support and one for with the Talos Linux. You can basically get it here. However, I must point out it is the 2204, so it's already a previous LTS version instead of the recent LTS version, which is 2404. Now, the next up is the repository I mentioned before from Joshua Riek, which actually is the one that also was responsible for getting the Rockchip support into the initial image that was provided by TuringPI. His repository actually at the bottom of the supported boards has the Turing RK1. And here you have the 2204 server desktop image, the 2404 server desktop, and the 2410 server desktop. And I'm actually going to go with the latest LTS, which is the 2404. So I'm actually going to grab that right now while we are discussing these images. Then finally, for the Compute Module 4, for the Raspberry Compute Module 4, you can actually grab the image from Ubuntu. So you can go to cdimage.ubuntu.com/releases. You can go to the most recent release for the Raspberry Compute Module 4, which is the 2404.1 release. And at the bottom, you will get a pre-installed server image, and here it is, the Raspberry Pi generic 64-bit ARM pre-installed server image, which is also for the Compute Module 4, which you, in combination with an adapter board, can use as one of the nodes of your TuringPI. So, in the background, my image already completed downloading. So now we're gonna get to the good part. We are gonna flash our OS to a node. Now, before we are gonna flash, there is one step we're gonna do first. This step is optional because you can basically run the command to flash the node from the WebUI or from the terminal straight with the image locally being sent over. What you also can do, and what I'm going to show you now first, is copy the image to the BMC, to the SD card, and then do the flash process from there and use the image from the BMC SD card. Now, I prefer this method. The reason for that is I prefer to have a copy of the image that's being loaded on a node to be stored on the SD card of the BMC. It's for safekeeping and also to ensure that, hey, if I need to reflash a node, I have the image on hand, regardless if the image is available online, etc. So I would like to have my own copy. That's why I recommend storing the images that you actually have active on your nodes to have a copy of that image on the SD card. Now, how we're gonna do that? Currently, my BMC is completely clean, empty, it's fresh. So I first am gonna show you how to log in with SSH, create a directory where we're gonna store the image. You can push the image straight to the SD card and then make directory, organize and move files around, but let's go with this setup first. And after the SSH, I'm going to show you how to transfer the image from your local computer to the BMC. Now, here's the thing. This is universal for all operating systems, Windows, Mac, and Linux. However, you might require the software to be installed. So in case of Windows, you need to go to features and have OpenSSH installed, or you're using WSL, Windows Subsystem Linux. Mac and Linux have all the basic tools we're going to use pre-installed, ready to go. So now we're going to get started. So open your terminal, and in this case, I'm using the terminal in the directory where I actually downloaded my image before in the folder images. Now, first, let's log in to our BMC to create our images directory on the SD card, because that's where I want to store the OS image. It's very simple, actually. So you start with SSH, and then you just provide username, in this case root, at TuringPI.local. It requests the password, which is Turing, of course, and we're logged in. Now, the SD card is by default mounted under /mmt for mount /SD card. So under mount SD card. So that would be a mount. Let's go to change directory mount, and then we have here the SD card directory, and there we have it. Now, if you want to know, hey, if it's really SD card and is there a command quickly to check what is mounted, etc., you can always check with df-h, and we'll give you an overview, and you can actually see that the SD card, I got the SanDisk of, was it 256. So yeah, here you can actually see that the SD card is mounted. But what we are gonna do is, we are gonna create a directory, mkdir, create directory, and we are in the SD card directory. Now, if you want to, I'm gonna show you the command of doing the shorthand from wherever you are on the system, so you can give the command and log out. So that would be mkdir -p for ensure parent directory exists, not needed in this case. And we're gonna create a images directory, and here it is. This will be the same as doing mkdir images in the SD card directory. It does not really matter, just making sure that you create a directory in the right place. Now we can log out. You can either do exit or you can do Control D. I'm most of the time a fan of shorthand Control D to log out. Now we got our target directory. Now we need to copy the image over, which is actually quite easy because there's a command for that called scp secure copy, which works basically in giving an address and then source destination. Now, the source what we have is /our Ubuntu image destination. Now, here's what it works is you're gonna give the same as we did before with the SSH. So username at server. However, now we're going to do a colon with the target location, which should be enough of simply giving root at TuringPI.local. And we're going to place this in /mount /SD cards /images. And let's shorten this whole name. Let's call it Ubuntu 2404 RK1. Well, we already know the RK1 is like ARM64, so just .image.xz. It will ask for the password, and there is being transferred. But it might actually be the limiting factor of the CPU power of the BMC itself, because the BMC is it doesn't have the same processing power as my laptop. The nodes have processing power, but now we're actually talking about the CPU of the BMC itself, which is normally intended to do networking operations. So yeah, there's no some kind of high-powered CPU installed on the BMC to have this sped up. So this is gonna take a few moments. Let's get some coffee. You enjoying the video? Comment below, subscribe, and hit that like button. It greatly helps this channel out. Now, let's get back to the video. And we're back. And there you have it. Image has been copied. Now, we're gonna log in again with SSH. So I'm quickly gonna go back to my SSH. Quickly log in again, just to verify that SD card, images, and there we have it. Name change perfect, nice shorthand. Now also, what I'm gonna do is I'm gonna read link.f, and by using read link, you actually get the current path. Why? We're gonna need that for flashing the OS. So let's get started on that one. So we're finally ready to flash. I'm going to show you two ways of how to flash a operating system to your TuringPI. The first one is through the WebUI. The second one is through the command line. Now, important to know is that when you do through the WebUI, you cannot actually currently use the image of the BMC from the SD card. There's an issue with the WebUI. Turing machines is working on it. So you might get an error, but you can still upload it through your browser. So that's what we're going to use. So you can actually go over to the TuringPI WebUI by going to https://turingpi.local. You might get a certificate warning. You can go continue, advanced, and then go to the unsafe and bypass it. It has to do with the fact that the certificate standard shipped or generated with the TuringPI is not recognized by your browser. You can actually fix that. I'm going to show that in a later video how to do that. But for now, you can bypass it and you can log in with the username root and the password Turing. Now, the first thing that you can do is you can go straight to the tab Flash Node. Now, I'm going to flash Node 1. I'm going to give it the image which we downloaded earlier, the 24.04, the LTS, the recent LTS version for Ubuntu. Now, the other thing is that when you download it, there's also a SHA-256 file you can download. In that file is a hash that can be used to verify that the image is correct. Also, there's an option of doing a checksum, which calculates like a hash of the file to make sure that everything is correct. Like it's just an integrity check. Now, because I know this image is good, I'm gonna skip it to save some time. So when you flash from the BMC, it should be about 8 minutes per gigabyte is what they say from TuringPI in how much time it will take. So image is 1 or 2 gigabytes, so it's gonna take at least 8 to 16 minutes. However, when you're doing upload like this combination, it can take up to 60 minutes per node. That being said, I will make sure that at some point you can just get a coffee and suddenly we're in the future. So you can just press install OS and it will ask you to override the OS to the selected node, and we're just going to press continue. Now, before I do that, another note is that the progress bar might still have some issues, meaning that it might stall or error out after 2.5 minutes. That is only a cosmetic WebUI problem. So the flashing will continue. Now, how can you check that everything went okay? That's actually fairly easy, because you can always check your router, because if the image is correctly flashed, then the node will reboot. It will get an IP address from your network, so it should appear in your router. And so that's how you know everything went okay and you're actually ready to log in. Now, finally, the default images that you're loading, they have a default username and password of Ubuntu. So the username is Ubuntu and the password is Ubuntu. Handy to know if you want to log in. So yeah, let's get started. So let's continue flashing the node, and here we go. So we can see the image is a little bit under a gig, so under 1 GB. So it should be about 8 minutes to flash. They say 60 minutes for the server image, so we're just gonna wait and see how everything is gonna work out. So I'm gonna get a coffee. See you in a moment. And we're back. So the image just finished a few moments ago. So it only took a few minutes to flash the image to the node, and just checked with the TuringPI itself. The node does not automatically turn on. So we should now be able to turn on the node and see if everything is working. So we can simply go with turning on node 1. Now, in order to turn on the node, you have to press the edit first, turn on the node, and there it actually goes. Node was turned on. Now we just have to wait a moment, and our node should appear on within our router on our network. So see you guys in a moment. So we're back. We're back with a terminal because I just checked my router and it looks like the TuringPI came online with an IP address. So I am now gonna see if I can log in. So that would be SSH Ubuntu, because username password is Ubuntu at 192.168.10.10 is what my router tells me. Do you want to accept the key? Yes. Ubuntu. Enter. You are required to change the password on the first boot. I am going to change it to Turing. Password changed. Let's log in with the new Ubuntu and Turing password. Da 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 da. We flashed our first node. Now, let's flash through the command line. You enjoying the video? Comment below, subscribe, and hit that like button. It greatly helps this channel out. Now, let's get back to the video. We're almost there. Right now, I'm going to show you guys how to flash a node from the command line. Now, just a quick note, if you want to know how to log in to a newly flashed node, the default username and password, the fact that you have to change the password on first boot login, I advise you guys to check out the previous chapter. For now, let's dive into it and let's get started. So I want you guys to open your terminal, and what we're gonna do is we're gonna flash the node. Now, it requires a TPI command. In an earlier episode, I installed it. If you did not install the TPI command, you cannot do it from your local computer. However, you can simply log into the PMC with SSH and run the command from there. But I'm gonna do it right now from my computer. Also, if you want to know the options of the command, the different options that are available, you can always use the dash dash help. That works for the TPI command, but also for its subcommands. So if you want to know the options of the TPI flash command, you would give TPI flash dash dash help or dash h. And it'll print you all the options. Now, I am quickly gonna show you how to do it. So it is TPI flash. Then we're gonna tell it to run it from a local data source. So with dash dash local, it allows you to run it straight from the SD card, which is where we installed the image earlier. So dash I for the image path. Well, I've copied the image path of on the SD card earlier. Then we're gonna tell it to skip the CRC check, and I'm gonna flash node 2. So here we go. Let's flash node 2. Now this is gonna take a moment, so I'm gonna see you guys in a few minutes. And we're done. Now you can simply use the TPI command to power off your node because it's probably still in flash mode, or you just reboot it by turning it off and then turn it on with the TPI command. You can actually do that by through the TPI command by TPI power sub command. So TPI power and then dash n or dash dash node and then the number of the node and then on or off. Quite easy to do so. But yeah, this is how you flash using the command line. Now, this was how to flash an operating system to your nodes of your TuringPI. I hope you enjoyed it, and I will see you in the next video.